Robert Varish had found a treasure, but didn't realize it until 18 years later. For over 20 years, Varish, long addicted to rock hunting, combed the Mojave Desert north of Los Angeles. Days were spent working as an engineer at NASA's Jet Propulsion Lab in Pasadena, but come the weekend, he'd be out there searching for pieces to add to his collection.
Oh yeah, I've been interested in rocks and minerals all my life, and I can't say why. It's just like that's what you're going to be interested in. That's going to be your interest for the rest of your life.
But in recent years, rockhound Varish stopped looking down and is now looking up at the sky. He has focused his collecting on the rarest of all mineral finds, fallen meteorites.
I started becoming interested in meteorites when I saw a fireball on the way back from a trip from the desert. That got me into the subject.
Meteorites lose about perhaps up to 95% of their mass coming through the atmosphere, and sometimes all that's left is just smoke, and oftentimes what's left is just a small remnant of what originally hit the top of the atmosphere. But some meteorites observed to hit cars, many hit houses, but most, of course, fall in uninhabited areas and are not observed.
When a meteorite first hits the atmosphere, it begins to glow, heating the air around it, encountering more resistance as it speeds downward into denser layers of atmosphere. These frictional stresses can break the meteorite into little pieces. The fragments start diverging as they finally fall to the ground, forming an elliptical pattern, which we call a strewn field.
This one meteorite here, Holbrook, fell in Arizona in 1912, and about 14,000 pieces were recovered. These pieces just littered the ground all over the place, and they were just picked up by bushel baskets. And some meteorites are just observed as a single piece, and others have fragmented into even more than 100,000 specimens coming down.
Varish couldn't possibly be looking for anything more difficult to find. Most meteorites that survive the superheated trip through the atmosphere hit the ground so hard that they bury themselves on impact.
Meteorites are very rare on the surface of the Earth. You could go all day long in most regions and never find one. So you want to look at areas where they're likely to be more concentrated, in areas where there are very few terrestrial rocks to be observed, and so any rock that stands out could be a meteorite.
Varish looks in the desert, where meteorites, which are usually dark in color, are a lot easier to spot, at least those visible on the surface. The others are located with the use of metal detectors, or even sticks with a magnet attached to the end. But what Varish didn't know was that there was another location much closer to home where he was going to make the most extraordinary of finds. Over the years, Varish amassed quite a collection of specimens, all kept in an area beside his house. That was until his wife Beth got tired of the mess outside and insisted he do something about it.
And at best, I'll wash them off, and then they'll just get stacked with the rest of them. And that's usually about as good as it gets sometimes.
To please his wife, Varish agreed to sort through the collection and discard everything of no value. And if something very special had not caught his eye, Varish might have lost forever one of the rarest mineral finds in the entire world. What he found were two small blackish rocks, something he had forgotten from years past. But now he was able to recognize what he had missed when he first collected them 18 years earlier. What he saw was a color and texture that said meteorite, but the idea that there might be two of them just sitting in the rock pile in his backyard was hard to believe.
On the day that I found the meteorite in my backyard, it was a shock to me, and from that day on, I've been thinking hard about why I even bothered to collect that rock. And more importantly, where, I can only tell from the rocks that were in the box with it that it's probably the Mojave Desert that I collected it. It's just I did so much hiking and taking trips out there that it's numerous places it could be from.
Varish knows that where you find one, or in this case two fragments of a meteorite, there are likely to be more.
A researcher looked at the question of how many meteorite fragments there are per individual fall, and he concluded that about 5 on average. And so if you find one meteorite there, there's a good bet that there may be additional fragments in the vicinity within a few kilometers, and it'd be a good place to look.
Varish decided to try retracing his steps, hoping to find the original location, where there could be more fragments of the same meteorite to be discovered.
These strewn fields form over many miles, depending upon the angle of entry into the atmosphere where these pieces fragment off, it doesn't tell anybody that's the exact spot that it was found.
But there was something nagging at him about the two small meteorite fragments. He couldn't match them to any of the pictures of other meteorites in his reference books. Was it possible they weren't meteorites at all? Varish decided he needed the help of an expert, so he brought them to Alan Rubin's lab at UCLA, which confirmed they were meteorites. But he wasn't prepared for what he heard next.
When they started saying that they saw a mineral called masculinite, I mean, that sounds technical, but to me, I knew that was something that was found in Mars rocks, and I said, oh my goodness, they're talking certainly probably a Mars rock. So I had to be reserved. I couldn't be jumping up and down, knocking over equipment.
The presence of masculinite meant the two small rocks were in fact meteorites. Meteorites that had come from Mars. Only the 14th find of Martian meteorite ever discovered on Earth. And how do we know they actually are from Mars?
There's very, very high mountains on Mars, and a meteorite impacted probably a very, very high mountain, something much higher than our own very tall mountains here on Earth. And because Mars is a much smaller planet, there's not as much gravitational pull to keep it there, and energy from this large meteorite impact would get that piece of rock moving, and moving fast enough to escape the gravitational pull of Mars. It would get up into that area between Earth and Mars, and our gravitational field would capture this piece of rock, and in it would come.
The chemical composition of the two fragments matched the analysis of the Martian atmosphere as measured by the Viking landers.
It turns out I actually found one even before I knew what they look like. And I'm thinking, you know what, I'm going to be noted as that guy who sat on a Mars meteorite for 18 years. Not the guy that went out and found one, but the guy who had one in his rock collection for 18 years.
When Mr. Varish actually collected the Los Angeles Meteorite, there were actually two pieces. And because they were found in such proximity, they were given the same name. You can think of them as number 1 and number 2.
The Los Angeles Meteorite is the only one that's been found in North America. And since these Martian meteorites are considered the rarest on Earth, they have a value that reflects that rarity.
Since there are 14 of these on Earth, that's a lot of competition for pieces of 14 things throughout the planet. Years ago, a piece of a regular meteorite might be, you'd consider it $1 a gram for the metal, $2 a gram for the ones that were more mineral. Now we're talking an order of hundreds to thousands of dollars per gram.
In fact, Martian meteorites sell for prices starting at $1,000 per gram. Given the weight of the two fragments Varish found, we are looking at a value of over $500,000. But Varish has only sold one of the pieces. The other one is on loan to the Los Angeles Natural History Museum.
I really wanted this meteorite on display because it's a really beautiful meteorite. It's what we call oriented. It has very beautiful flow lines on it. It's classic beauty.
One of the fun things of meteorites is it gives us a chance to study our own planet. Many meteorites are pieces of material that are similar to our own planet that got fractured, broken up. And the metal meteorites that we study reflect the guts of our own planet. It's how we study ourselves from the inside out.
I'm trying to trace my steps of 18 years ago where I was in the desert when I found the LA Mars meteorite. And we're near some of the places that I was hiking and traveling and rock hounding in and prospecting in. And we've been lucky. We've actually found some chondrites, but we were not lucky enough to find another piece of the Mars meteorite. But hey, at this rate, we'll keep searching.
So Robert Varish continues his search for Martian meteorite treasure, hoping to find the strewn field where he made his original discovery, and at the same time, paying more attention to the specimens he already has.
Well, I would have to tell you that after finding the Mars meteorite and Mars rocks, I'm spending more time with my rocks and I'm identifying them better.
And what advice does Varish have for the rest of us who might want to go out looking for meteorites?
I can't stress enough to have a positive attitude in the sense of you're enjoying that you're out here, you're enjoying the warmth and the wind, you're enjoying it, and then it all falls in place then. And then they allow themselves to be found.